their jobs. So next we're going to play detective. There is some slide that I've prepared from the Tabula de Testare. Maybe some of you will know about that. 2016, I think. Let some identify how what type of skills do we need to be able to test. So we'll play detective next. So I will leave you 1 minute to read the context and see if you can identify the solution for this problem. Okay, I can see a hand raised. Alexandra, can you tell us what your opinion?
Well, one solution is that the poison was in the eyes, and because he left early, his eyes didn't melt, and other people got to drink their to drink the melted eyes. So that's why they got poisoned.
Very good, Alexandra. This is the answer for sure. Okay, very good. So this is how you think out of the box, right? When you play detective. Let's see the second context. Again, 1 minute. Okay, okay, Andrea, I can see that you have your hands up. Yes, please.
Yeah, I think it's Bill because he sells oil.
Okay, can you tell us how you identify this?
Yeah, if you read it upside down, the numbers look like letters. So it's the 8 is a B, 1 is I, 7 is L, but upside down, and you read it from right to left.
So Bill is the boss, right? He sells oil, right?
Yep.
Very good, Andrei. Let's go next, the last one. Again, 1 minute. Yes, so let's take Tudor this time.
Okay, so I think it's the maid because there said that it's a circular mansion, and she said that she's dusting the corners. So.
Right, very good, Tudor. Well, right, you are very good at identifying clues, right, and seeking, thinking out of the box and finding, let's say, solutions, right? So as you saw, there is some maybe relation between playing detective, right, and also if you think about detectives and testers. So let's see, and let's think about if you can state some similarities or maybe even differences between detective and a tester, and we will think about in terms of the subject of investigation, in terms of use tools, and of terms of duties. So anyone can interfere. So regarding the subject of investigation, right, what are the similarities between detectives and testers? What do you think? What detectives investigates and what tester investigates? Yes, Andrei, please.
I think they both investigate a situation that went wrong.
Very good, right? Detectives investigate something that harm others, right? Like a crime or something, some activity that was against the law, right? And tester investigates also what's wrong with the software, right? With the source code. Very good, Andrei. So they both investigate something. How about tools? How do you think regarding the tools they use to investigate? What are the similarities of tools between the detectives and testers?
The most important one, the coffee.
The coffee, yes, very good. Yes, I think that both use coffees, right? What other tools? Tools that use them in the investigations.
I mean, they seem quite different. So tester basically has his own mind as a tool, and the computer that he's working on, or the software that he's working on, while a detective has a more larger suite of tools, let's say, while also including, of course, his own mind of trying to solve things and maybe some computers as well, who knows.
Yes, maybe a detective could also use software application, right, to analyze different facts, right? He could analyze the blood on the crime scene, or I don't know, some hairs, right? Okay, Andrei. Thank you, Andrei. The other Andrei?
I wanted to ask, could we consider the clues to be tools?
Yes.
Okay, then the programmer or the tester would take some type of error, or the errors to be the clues. So they are the tools, and the investigator takes the clues from the crime scene, for instance.
Right. What else? What do the detectives have? They have gloves, right? When they investigate the crime. How about testers? What other tools? So Andrei Barzu mentioned about the mind, right? How they think about, right? The strategy that they make, how they correlate different events, right? So both testers and detectives use this in order to investigate the crime or the activity, and also the code, right? Okay, and how about the duties? What do you think that the job duties is related to detectives and testers? What do they have to do associated to the duties?
They must be unbiased.
Yes, very good. It's very difficult to be, especially when you test your own program, right? That's why maybe when you are a detective, you are not allowed to investigate on your own. I don't know, on your own related, I don't know, activities, right? What else? What do you have to do? What are your job duties as a detective and as a tester?
they must solve issues, sometimes signaled by others.
Mm-hmm. Okay, so somebody else will give you the job to do, right? What else do you have to do, for example, as a detective, after you have all the analysis, right? In the investigation, you have all the analysis of the blood, of, I don't know, the hair and so on. You need to go to the and testify, right, about the information that you find out, right? Such that you help the lawyers to make the bad guy go to the prison, right? In this respect, what do you think a tester has to do if you make a parallel to this? So a detective must testify, right? What the tester do you think had to do with this?
He reports the bugs and the issues found to the programmer, and the programmer then fixes them.
Exactly, right. So this is the same similarities with this one. So what we have discussed until now is that from the subject investigation, the detectives investigate some harmful act against the public, right? And a tester actually investigates a computer program, right? This is some instructions, and also it's related about the communication about the human computers. From the tools, right, the detectives take statements, has record equipment, evidence kit, gloves, and so on. However, the tester has some strategy, right, has a test plan, use different management tools, screen captures, right, different techniques to test. As you said also earlier, you need to have a certain mind, right, think about the solution and so on, some bug reports. And from the job duties, after researching and analyzing the crime, you also need to testify in court. The same in test. After you do the search for information to identify if you find out a bug or not, you also need to advocate for your bug, right? You need to go to the developer, as Ada said, and say, okay, I found a bug, please fix this, and so on. Okay, something happened. My office turned off. Why is that? Okay, that's strange. So we talked until now about what skills we have. We see some parallel between detective and tester, right? We need to do something. And what's important is that when we talk about testing, we don't even know what crime has been committed yet, right? Because we need to find out the actual bug. We don't know if the bug actually exists. Let's talk next about why do we test, because this is also an important question. Test. Before going to answer these questions, I added here some definition of testing, and you can find in different books and different, let's say, articles and over the internet, incomplete definitions about testing as being the process of demonstrating that error are not present, or the aim of testing is just to show that a program performs according to the requirements, or that prove that program does what it is supposed to do. However, those are incomplete definitions. You can also find various aspects of testing in the book of Myers, since human beings tend to be highly goal-oriented. It's very important that you, as a tester, set your goal to actually find the bug, not finding the bug. It's very difficult to switch your mind from a constructive process to a destructive process. So basically, you do not test your own program, right? Because first you added effort in creating the software, and then it's very difficult to switch to be destructive on your own creation, let's say. And also a very important definition of testing is regarding the successful and unsuccessful keywords, let's say. So the idea that the aim of testing is to find bugs. So actually it's the other way around. When we found the bug, we said we are successful. So the successful part is when we found the bug, not the vice versa. Another important issue that you find is that an error is also if a program does not do what it is supposed to do, but also if the program does what it is not supposed to do. So even if it's not in the requirement, even if is not specified. From those definitions, the that I like is the one of I found out in the BBST class, in which the testing is defined as an empirical technical investigation conducted to provide stakeholders with information about the quality of the product or service under test. Now, if you take the parts of this definition, so this empirical technical investigation means that you conduct some research, some investigation on your project, on your application. However, it's empirical because you don't really find all the possible bugs. You need to use different techniques and so on. It's a technical because you need to have some technical skills. You need to apply some steps, some approaches, some techniques in order to find information. And the aim of testing is that you can find information about the quality of the product. And we will see later that this quality of the product means either that you find or not the bugs, that if the application is ready for the release or not, and so on. And the most important fact is that this information you need to provide to the stakeholders. So for those that actually are directly involved in the use of the application. To answer this also to the same question, why do we test, it's also important that we understand two important things. That when we test in context, and we have different constraints that we need to fulfill, like schedules and budget, and maybe limited skills of the testing groups and so on. We can do testing in different phases of the development. So before having the release, during the release, or after the release. Our aim could be either to improve the project or just find out bugs. And we need to test in behalf of the stakeholders. That could be either the manager, the customer, or the programmer, or even an attorney if we talk about some law issues. So as we talked earlier, that we said testing is an empirical technical investigation to find out information quality of the product. So the most important thing in testing is our information objectives. Why do we test? For whom do we test, right? And these you can find several aims of testing. For example, it could be the aim to find bugs, but could also see information about helping managers with different decisions, either that we talk about the release of the project or the progress and so on. Or we can also do testing to help the clients improve their products, right? So also depending on the aim of the project, our information objectives is different. So this is why we do the test. The next thing is, the next important question is, how do we test, right? In order to answer this, I will also next would like to leave you again 1 or 2 minutes to think about this context. So how do we test? In this context, we have 3 contexts. This is the first one. I would like you to think about what is the aim. So what is the information objective that we talk here, and what is which are the stakeholders, for whom do you test? Okay, so take a minute to read about it. So what is your information objectives of testing, and who is your stakeholder in this case? So what do you think? What is the aim of you as a tester to work on this context? What do you need to do? Anyone?
Make sure that the project respects the requirements that it should respect, so it doesn't steer off and do more than it should or less than it should.
Okay, so who you actually help the programmers to see if the code that they deliver is the one according to the specification, okay? Okay, and who is your stakeholder? For whom do you test?
I guess the teacher.
Yes, the stakeholder is the teacher, and also in the background, let's say also the programmer, because you work for the project manager, that is the teacher, right? Because you are going to help the teacher to identify if the code is the right one, right? And eventually you also help the programmers, right? Let's see the next context. What is your information objective here, and which is your stakeholder? So what is the aim?
I guess the stakeholder is again the teacher. But the scope is quite different, because instead of trying to steer the project in the right direction, now you already have a project and you're trying to check if it has any errors in the integration side of things.
Exactly. So the aim is different now. If in the first place the aim was about the code, right, the clean code, here we already have the code, and the aim is more on the integration part of view. In the both cases, the stakeholder are kind of the teacher, but maybe now it's more clear that in the first context, the stakeholder are actually the programmers, because in the background, let's say, yes, you present to the teacher, but actually you have the programmers, right? And now it's maybe better emphasized that in the first context, the stakeholder are the programmers, right? And the second context, the stakeholder is actually the project manager, the teacher, right? Do you agree?
Yep.
Okay, let's go to the last context. How about this one? Again, what is here the main purpose and who is the stakeholder?
The aim here is to help the project manager with the decisions to see exactly if the application is ready to be released or not. And the stakeholders will be also the project manager as well as the doctors.
Yes, very good, Karina. Thank you. You're right. So the aim here is to have the project manager to take the decision if the product is ready or not for release. And the stakeholder here in the first is actually the project manager, right? But actually you work for the doctors, right? The stakeholders that you need to fulfill their needs are doctors. Very good. So as you see, how do we test, right? It's very important to acknowledge that we test in context. you can be assigned to a project as a tester either in the early stages of the project, if you need to also test the source code, or let's say in the middle part, for example, if you think about more integration part, right? And even at the end, if you need to provide the stakeholder or the project manager with decision to help with the decision, right? So it's very important that we acknowledge the context in which we test. Another important issue about how we test, it's different concepts about strategy, approach, and technique, because you will find those three words in some of the books similar and so on. So I wanted to emphasize the difference between them. So when we talk about strategy, if you look on the dictionary, sorry, strategy is more like a very large plan of action, right? Very long term. You have you look on some month, in 1 year, you have a strategy to work on. When you think about approach, you think more about the steps that you need to take in order to solve that problem. And when you think about the technique, you think more about technical skills, methods, step by step, very technical steps that you need to fulfill. If you think about this in general, let's think about how you brush your teeth, right? Your teeth. First, you have a strategy. Your strategy is that you will brush your teeth for the entire long year, 2 days of 2 times of the days, right? And maybe you can go to dentist twice a year, for example. This is your strategy, right? A very long term strategy. If you think about the approach, you think about the methods, maybe your approach is to brush all your teeth, the upper part and the lower part, right? However, if you think about the technique, you have a certain technique. You need to brush also the all the teeth one by one, for example, or maybe start upper and then go down. Also have the brush in different direction and so on. So this is about the technique. So again, when we talk about testing in general, we have a strategy, we have an approach and a technique. And when we talk about testing strategies, we talk about what technique and how we can use those techniques in order to test our project. When you think about approach, it's a way of thinking about applying the test strategy and the methods. And we think about testing technique, we think about specific methods that you can apply with certain steps in order to have that information objective fulfilled, either that finding the bugs or quality of the product or helping the decision about release and so on. So again, about testing strategies, it's very important to stay on this slide for a moment, because this will help us to identify the best techniques that fulfill our needs. And in order to select the test strategies, as we talked earlier, the most important drivers or elements that can help us in identifying the strategies is the information objectives. Why do we test, right? And the context in which we test, as we had seen earlier, right? How much is the team, for whom we test? Do we test, do we know more about the product or not? Are we in the start of the project or at the end of the project, and so on? So in selecting the test strategies, the information objectives, why we test, and the context in which we test are very important. Here you have some example of context factors. So which are the stakeholders that we talked earlier, right? Which are the goals, the quality criteria that are specified in the requirements, what skills are available and resources, the skills also in terms of the testing team, right? Maybe are some senior tester, maybe are some junior tester, and so on. How much time we have available to test, and so on. What are the consequences of failures? How the application could fare, so on. So these are some of the context factors that can drive our testing strategies. And regarding the information objectives, as we discussed earlier, maybe the aim is to find bugs, as was in the first context with the teacher, if you remember, or maybe to assess the quality of the product, or maybe the integration, if you remember in the second context, or maybe also help the project manager decide on the release part. So those two drivers, context and information objectives, can help us to select the best strategies. So how we select actually the testing technique, right? Because after we select the strategy, we also need to select the technique that we actually going to be used. A very important thing about testing techniques is that they differ in core, and as we need them for our health, for example, because you need to select different meals, right, different elements in order to have all the vitamins and all the minerals that you require to function well as the body, right? You select different elements. This is the same that you have to do also from the testing techniques, because some of techniques have different benefits, let's say, right? Some of the testing techniques are powerful, being able to find critical bugs, for example. Some of them are credible, right? Because means there are a lot of users, let's say, that will do those steps that you select in the test case. Or maybe some of the test cases are very reusable if you talk about changing in the source code and you make slight modification and you still need to check that the program behaves as intended, right? The same as maintainable, right? Easy to evaluate. That means when you want to evaluate to see if what you have run actually is true or false, right? Or it's according to the specification. It should be very easy to evaluate. If you do need to write a different script to do this, it's not a good test. So again, when we select a testing technique, we need to think about different benefits of it, and we need to select test cases or techniques that can complement each other to fulfill our needs. Here you can find a lot of techniques, a lot of testing techniques. You can go to the testingeducation.org in the BBST class, and from slides 77 to 72, there are a lot of testing techniques that are basically split on different criteria. If you think of the coverage-based techniques oriented to the tester, oriented to the risk, right? What are the possibilities of the application to fail based on the activities, evaluation, and so on. So there are a lot of testing techniques that you can use in your testing strategy, let's say. Another important question is about how do you organize the process of testing, right? Because we said earlier that it's an empirical technical investigation, right? You need to organize something. So as we talked about earlier with detectives and testers, we also talk about having a mind, right? Having a way of thinking, right? And in this regard, when we talk about testing, and your testing, right? The tester need to communicate what they need to do with the developers, with the project manager, right? You need to communicate the phases of the testing, what techniques, where in the points, and so on. You need to have a test plan, right? Some schedules, some bugs reporting, and so on. And why we need to plan the test cases? Because it's in testing is also important the organization. So to be organized around the development stages, you need to be able to repeat that test cases changes are occurring, or in case that you find some bugs and you need to reproduce it, right? You need to be able to track what we have done earlier. Maybe you have different version of the application and you need to see, okay, how was this new version behave for this, I don't know, set of steps relating to the previous version and so on. And for some of the projects, you need to have a proof of testing. There are some applications that are critical in which all the testing steps and all the testing activities need to be well documented, and you need to have those documents in order to get the application accepted and to be paid from the client. Okay, and I have also create verification and validation matrix. So this is some example that based on some real examples, we managed to create it for what we are going to do for the software system verification. This is for 2017 created, so it may not be the same how I ordered the laboratories now. However, you can see here that we have different components that are tested. We have also verification activities, but also validation activities. So again, when we talk about verification, we talk about the process, and when we talk about the validation, we talk about the product. As you can see, we have here different verification activity that is also about code review, but also about the unit testing part, and also architecture point of view. Right, so there are a lot of from the testing plan. There are a lot of views, right? Who's going to do this activity? When? This is related to the laboratories, and also when we talk about the validation, again, this is done by the stakeholder, right? And also this validation of the product is also could be done for a different team. That is acceptance testing. So this is how it works in general. A testing plan, which test design you are going to do. So this is unit testing, this is integration testing, and then you can have different test cases created from different requirements. I can see here A, B, C, and also reports of different aspects. If you talk about specification or coverage reports of the source code and so on. So this is how a test plan should look like. This is a very small example. So planning is also important. How about the test case? Because we talk about designing test cases. So when we talk about test case, you need to specify different aspects. You need to specify the domain of the test case and also the expected result. So there are also some issues or some thinking about what test case, what is the best test case, right? When you design one. So when you design a test case, you need to think that it's not redundant, it's not repeated, it's not. When you create a test case, you think about that information objectives, right? If you meant to find errors, you create one that actually reveals the errors, and you will not create another one with the same coverage, let's say, of the behavior. Best of breed, let's say, if you have a set of test cases that kind of test the same kind of behavior, you should select the best one that is the best representative, and should be not too simple, not too complex in terms of how do you identify, how do you identify the failure or pass, right? How you identify the expected results, and also should not be very difficult to be implemented. Regarding testing activities, there are different activities that you do when you test. Basically, you first identify your information objective, what is the function that you test, what feature that you test. You need to think about the inputs for that feature. You need to think about the expected output. Then you execute the environment, and after you execute the program with the environment parameters, you need to also analyze the results. Basically, you need to think about if the inputs and the expected outcome are the same with what you actually obtain after executing the program. Another important issue regarding testing is how do you organize the process of testing. In the same idea is that we also need to report the bug. So if our aim objective is to find bugs, we also need to be able to identify how we can report a bug, right? There are some principles that you can also read in here in the book of Peyton. You need to report as soon as possible. You need to describe effectively the bug. You need to write the condition under which the bug was revealed, right? And you need to also be non-judgmental. You don't have to pick finger points, oh, this is a very bad bug, and so on, right? There is also some issues about reproducing the bugs. You need to specify the version of the application, the context, the environment under which you tested, and so on. So it's a lot of different aspects that you need to think about reporting a bug. And we are going to do also a seminar about that, about some frameworks that can help us to write a good bug report and how to advocate for your bug. Regarding a bug life cycle, there are different scheme here. A very simple one. After the bug is found, it's open. Then the assigned developer to solve the bug. This after the bug is solved, it will be closed. And there is also another more complex scheme in which basically from the resolve, it could go again to open, maybe because the tester found that still the same bug could be reproduced in other contexts, similar contexts, and so on. Or maybe you can go from the review to be defeated because it's not worth correcting, fixing the bug, or maybe after the review just close it and it's not a bug, it's a feature, right? So depending on different aspects of bug advocate, right? To advocate the bugs, there are different action. Then you can take one. You found the bug. A very important aspect is when have we tested enough? How do we know that we have tested enough? So because when we test, we have this domain from which we select the input data. If you talk about black box testing, right? It's very difficult to apply an exhaustive testing because it's not possible to test with all possible inputs, right? That's why we have to have some strategies to select a subset of the test cases from that. And we will talk about that later. If you would like to learn more about the impossibility of complete testing, I will invite you to read this paper. They actually did an exhaustive testing from one project, and they actually found out the bug in this way. But this is not possible to be done in the project. These are the required reading that I told you at the start of the lecture today. So there are some testing principles and testing axioms. There are some pages to read about. So, for example, pesticide paradox, why it's important to not throw away test cases, and so on. So I invite you to just read a few pages about this, and we're going to talk about this in the second seminar. It will let's say, improve your way of thinking of testing and see more, let's see, details that, as I told you earlier, we can discuss for hours about testing. So I will provide you the pages, and please make sure that you read them before the seminar. Another important issue is when we test, right? So when we test, if you think about the software development process, you know those steps that starting from the end user, we have the talk, we have with the client, we have the requirement, then we have the objectives of the systems, then those are translated to external specifications such that the developer will be able to start working on them. We have the design of the system, the split on the components of the application, then we have the module interface, the code, and so on. And then we talked also earlier about inspection and code review. And we also saw that for every steps, so or every steps in the development, we also have a verification part in the review, in which before going to the next stage, we need to review the first state, the current state, in order to make sure that we start from a correct documents or artifacts. And also in the testing process for each the step of the development, there is also a testing phase. For example, in order to validate that the proper requirements were implemented, we have acceptance testing, right? In order to see that all the objectives of the application were fulfilled, we need to test system tests, right? Because we will go through the interface, go to the backend, and then go back to the interface to see that the entire features was actually implemented. Then we talk about external specification. We talk about function test or feature test or unit test if you think about modules. And also if you think about the system design and the structure and so on, we talk about integration test and module test. Another important issue is about levels of testing. As you discuss in here, you can see there are different steps when we apply testing, right? If you think about the module testing on the function test, right, about unit testing in general, in which basically we think of testing of a unit, a port, a procedure, or a method, or a function, or I don't know, subprograms of the larger building block, right? In unit testing, when we design the test cases, we design with two aims. Basically, we can have the access to the source code, and then in this case, we apply YBOK testing, or we can only have access to the specification, and in this case, we design the test cases starting from the specification of that module, that function or procedure, and so on. When we also talk about unit testing, it's very important to acknowledge that it may be possible that if the modules that we are going to test depends of other functions, those are called stubs, some of those functions may not be yet implemented. So to overcome this situation, we need to implement sub-stubs, basically that are routines that took place to the real source code that eventually will going to be implemented, such that we can be able to test our modules. Also, the driver is actually the upper part of the application that actually calls our module. So again, when we talk about unit testing, we need to think about how our module, our procedure or method is actually integrated in the entire architecture of the application. And if it's somewhere in the middle, we need to think about the modules or other functionalities that our module depends on, and we need to replace these modules with stubs. And also, if you think about the upper part of the application, we think about the driver, basically all the parameters or the environment elements that are required for our module to be called. Okay, those are some references. And next we're going to talk about black box testing. However, before going next, I would like to ask if you have any other questions regarding testing in general, because we talk about, let me just show you the, where is that's it, this one. So before going next to black box testing, I would like to give you a moment to think about if you have any other questions about, let's say, testing in general. Yes, no questions?
Yes, no.
Okay. So once again, testing is very large concept and we can talk for days and hours. Okay. Let's go next to the next presentation. And since I also wanted to have time to show you the source code, I would also like to take some time. So maybe I will go faster for the presentation, but I will show you, we will also be discussing about black box testing during the second seminar and the second lab. And I would just want to show you also the Testing and the Jenkins. So today we're going to see how we can design the test cases, starting from the specification, that is black box testing, and we're going also to see about how can use TestLink and Jenkins. So from the black box testing technique, it's actually included in a more broader view of testing that is also called domain testing. And there are a lot of techniques that you can apply here. So this black box testing is more like an approach that you can use either to black box test, either to unit testing or system testing in general, also integration. And we're going to use today equivalence partitioning and boundary value analysis. We also talk about advantages and disadvantages and see an example of how to apply this equivalence partitioning and boundary value analysis. So first of all, about this domain testing, as we talked earlier, we saw that it's not possible to have that exhaustive testing with testing all the possible inputs, right? So we need to have some way, some strategy in order to select the best test cases or the best inputs of that domain, right? In order to be able to find the bugs, right? To have the highest probability of finding bugs. And in order to do this, domain testing help us with this sampling strategy to select the test cases. And equivalence partitioning and boundary value analysis are some of the techniques. When we talk about domain testing, we can apply those equivalence and boundary to either the input or output variables. So we can start from the input data and the preconditions, that are condition on the input, and results and post-condition on the output. On the BBST classes, there is also another view of domain testing that we are not going to discuss, but I just wanted to mention that is also a strategy that you can apply to a primary dimension of the variables and also a secondary dimension. So primary dimension means that you think about the data in the methods, right, as the primary dimension, why the data is there with that purpose, right? And the secondary dimension is about to think about other meanings of that input to other relations. It's a much complicated way of thinking, but it could help you design better test cases. So what is equivalence partitioning and boundary value analysis? Equivalence partitioning or equivalence class, you can find definition of in the book of Mayers, is basically a way of thinking of the input of the domain that you partition the input domain. And then after you split the domain of that variable in different classes, you can select one test cases from that partition, that class partitioning, and saying that, okay, if I will pick element from this equivalence class, then the application behaves in the same way. It doesn't matter which data I'm going to select. How we can identify these equivalence classes? There are some steps. So you need to design first valid equivalence classes and invalid equivalence classes. You can also think about default, empty, blank, null, zero, none elements, or also invalid, wrong, incorrect, garbage, date. So we will see how we can do this. How you define basically the test cases after you find identified equivalence classes is that you need to select and assign unique equivalence class for each unique number for each equivalence class, and then until you cover all the valid and invalid equivalence classes, you need to select test case. Because we talked earlier about non-redundancy, right? And about not writing more test cases with the same behavior, is that when you select a test case, you create one, you select one that covers more of the valid equivalence classes, because you have to minimize the number of test cases. By minimizing the number of test cases, you minimize the time execution, right? And so on. And however, for the invalid equivalence class, you need to create one test case and only. Here are some examples, for example, of boundary value analysis, some guidelines. If you have an interval, you need to create one valid equivalence class for a test case inside the interval, and two invalid equivalence classes from outside the interval, right? And so on. You can read more about this, and we'll also be able to practice more on the second seminar and on the second laboratory. From the boundary value analysis is that in order to create test cases based on this method, you need to also create test cases at the boundary of the equivalence class. So if you think about the equivalence class for the A and B values for the interval, right? When you select equivalence test case for the equivalence class inside the interval and outside, right? Here on the boundary value, you need to select exactly at the edge of the equivalence class. So we will select a value for the test case with A, B, A minus 1, A plus 1, B minus 1, and B plus 1. So the difference with boundary to the equivalence class is that you need to select test cases with values exactly on the boundary of the equivalence class. Some advantages and disadvantages as using using black box testing is that we can apply and design test cases even if we don't have implementation yet, right? The person that performed that designed the test cases are independent of the programmer. It's some other person. We start from the specification. That means you have the user point of view. We can also find ambiguities in specification if we found them in inspection or code review, right? Or review, let's say. And we can apply it. You can start using black box testing strategy immediately after we have the specification completed. So we don't have to wait until we have the source code. As disadvantage is that only a small number of inputs will be designed because of the equivalence classes partitioning. You may have not clear specification, will be very difficult to design sometimes. And we could also have some repetition of tests that are not necessary because of not that integration part. And what is the most important disadvantage is that we don't know which path of the program is actually being tested because we don't have the relation with the implementation yet. We don't know how the program will be implemented. We just know some cases, right, from this perspective. So in this case, many of the paths in the actual implementation would remain untested. That's why it's important to also apply whitebox testing. Basically, make sure that you at least test all the source code. Okay, before going with the example, I would like to ask if you have questions until now about black box testing. Okay, I guess not. You're still there, right? Right?
Yep. Yep.
Okay, so we talked until now about black box testing and see how we can design the test cases, how we split and have a heuristic way of finding the test cases. Next, I will give you an example. So this is a very short example, how a problem compute the number of participants with the maximum score at a competition. So we have a set of participants, each participants have a set of points, and we need to find out which are the participants with the maximum score. And we have applied equivalence partitioning and boundary value analysis. And let me just show you the document. So it's very important when you do testing, if you do script testing, to also think ahead of the test cases. So this is the problem. This is specification, the input data, output data, the results, precondition and postcondition. So as input, we have an array, and each element of the array is actually the points that the participants I get of the context. And as output, we have all the participants that get that maximum points. So when we talk about equivalence classes, we said that we take all the input variables. So in our case, the input data is n, how many participants we have, and the list of the participants, right? So we can split the first condition n to be in either valid equivalence classes or invalid equivalence classes. As you can see here, we have a class. So starting from the same condition, we have two classes. We have one with natural and one with not natural. Then we think about the points for the participants. This element could be also be natural, could be from 0 to 100, but could also be outside the condition, less or greater than 100 experience points. Again, another condition to be natural number, then this number of maximum participants that could be have the maximum value. Another discussion, this n max should be between 1 and n. This is n is the number of participants, and so on. Now, after we have the discussion with equivalence classes, we also need to construct the test cases. As I told you earlier, the idea is to come up with a minimum number of test cases, right? So when we create the set of test cases, we need to create a test case that will cover as much as possible from the valid equivalence classes. And for the invalid equivalence class, we need to construct one test case and only to make sure that each invalid is separately tested, right? So here you have those cases is with invalid equivalence classes. And here are some test cases that are based on the valid equivalence classes. So as you can see, the first test case number 1 that has 6 participants with those points covers test case equivalence class 1, 3, 6, 8, 12, 17, 20, right? So natural here, natural here, natural here, here natural, and so on. So all the positive elements or the positive or the valid equivalence classes could be covered with one test case. So after we have designed the test cases, you can see that it's also possible that some of the test cases that we have designed could be implemented. It's because when we talk about the condition, we also start from the output, and sometimes the output could not be, let's say, on purpose created wrongly. Another important aspect that I also wanted to told you is that, yes, when we talk about equivalence classes, you can start from the conditions. So these are only from the condition of the specification. However, because as you told earlier, we can have our own way of thinking. You have different skills, let's say. You can also use your way of thinking to design new test cases. So for example, you as a tester, if you have experience, you can think about how many maximum value do you have, right? It's not here in the specification that you have to come up with that. So you can have one single maximum value, so only one participant with a maximum value, or you can have all of them, right? All the participants took the maximum points, or you have only few of them. Then you also think about the position of the maximum value. Is in the first position, last position, middle position, and so on. So all those way of thinking of either the input or the output can help you design different equivalence classes that you can design then later better test cases. Questions until now? Okay, I will go further. So after we have the test cases on the equivalence classes, you can also think about boundary value analysis. So as I told you earlier, we can start from the equivalence classes for each condition, and then when we pick the test cases for the boundary, we can pick exactly at the boundary of the equivalence class. So for example, we know that n is natural, and this n could be from 0 basically to 100. That was the maximum number of participants, right? 100. Then on the boundary, we can have exactly near 0. So we have 0, -1, and +1, and near 100, +1 and -1. So again, this discussion about the each condition in the equivalence classes. Then when we create also the test cases from the boundary value analysis, starting from this table, you can see that maybe some of the conditions are repeated. For example, in here and in here. So after you have until now we have two tables, one table with equivalence classes and the test cases associated to them, and one table with the test cases created based on the boundary value analysis. However, if you compare them, you will see that some of the test cases are the same, right? And because we don't want to have redundant test cases and duplicated, we will create the last table in which basically we have no redundancy, right? As you can see here, some of the test cases for the boundary value analysis are the same with the equivalence classes. So for example, test case from the equivalence classes 4 is equal with the test case of the boundary value analysis 17. So instead of having two test cases with the same input and output, we merge them in one single test case. So this is very important to do. So this was the first part. So it's very important how we design the test cases, because we want them to find the highest probability of finding errors. We don't want to have redundant. We want to make sure that we test with the best representative, right, of the equivalence class, and so on. So after we design the test cases, we also implement them. And this is the source code. So this has the same Maven project that we already had from the laboratory 1. Some of you will have this week the laboratory, in which we have the part with the source code, and also in the Maven project we have the part with the test case. As you can see here, I have the same problem with the max point participants, and here I have created some of the test cases from the from here. So for example, I have a case with all participants having the maximum points, all the participants but only one have the maximum points, or participants with 99 points, right? If you have the boundaries from how many points a participant can have, right? So now that I have the test cases, of course, I can decide to run them here, right? And I can have the output, the execution here, right? Or the test managed to execute and found no errors, for example. However, if I'm working in a team and I would like to also improve the application, I would like to also test in regression testing, and would like to have all the available as a tip. So in order to have this, 1 second, I have 2 tools, and one of the management tools is TestLink. That in here I have all the test planning tools that we talked earlier about, and in Jenkins is just a tool that can help me to build and execute the test cases that I have created in each phase of the development. So since we have only about 5 minutes till the end, I will go further and explain to you, and maybe next lecture, I will take again the presentation, since we will talk only about white box testing and we'll have more time. But I just want to go you through these 2 tools, because you also use them in the second lab. So TestLink is a test management tool that you can use to plan your test cases and have their here all the test cases assigned or test suite and so on. And then you can also match them with Jenkins to see the jobs. So for example, here is the test project. You have different projects in your IT firm, let's say. For example, this is the project that I have created. Where is it? This one, not this one. This one, project maximum points participants. You can see that here you have a project for each of your groups. So this is the project you're going to work. However, today I will show you, this is the test project. And for this test project, I have created a test plan. You remember the test plan with the verification and validation metrics, right? You have here some plan, black box testing, white box testing, incremental, and so on. So this is the test plan. It's a abstract concept, right? And in this test plan today, I have created in the test specification. So this is the project maximum points participants. This is the test suite that I have created for the black box. So this is testing this feature of the application from the black box perspective. And here I have added the test cases for the, where is it? For the, they close it. This one for the application, right? So one of the test cases. Okay, so this is the test project, the test plan. As you can see, the test cases is it's here, it's created. And another important issue is that this test case needs to be linked to the job in Jenkins and to the application that I have in GitHub, right? I need to specify here the name of the autotest class and also the name of the autotest method. So there are 2 parameters that are used. This is the test class. You also need to mention all the packages. And here in the second parameter, you need to mention the test method, the test class DS, followed by the test method. As you can see, this test case is added to the project test plan. And when I will go to Jenkins, because in here in Jenkins, I have this job. In the configuration, I have here specified where you can find the source code from the GitHub. Okay, and it's not this one. This one. Okay. This is the max point participants from GitHub, and I also need to specify here the project name, right, that I have here in test link, and I also need to specify the test plan. So the test plan was this test plan that I actually added my test case to this test plan. After I will execute the project, this one, right? If I will go to testing results, oops. Okay, if I go here, right, you can see that they have identified that in this project they have identified one test case. This is this one and was passed. And if I will go next to the test link, instead of go to the test specification where I have the test suite along with the test cases, I can go to the execute test. And you can see here that for the same project, I have this test case being executed and I have here passed. Of course, I can have multiple, I can have here other actions, I can have reports sent by email and so on. The idea is that after having the, and I will finish and I'll have only the last presentation. So to sum up, it's important from the specification point of view to design for the test cases, to come up with the best and minimum set of test cases that is best representative for the domain of that application that you test. Then after you have the test cases, it's important that you also implement the test cases, right? This is the source code. And then you have some test management tool that can help you track all the test cases that you have created, executed, which are passed and which are failed. And we have done this with TestLink management tool and project from the Jenkins. So I haven't managed to do live presentation. However, you have here all the data. I will send you also the example and we'll see how you can also access those links, those APIs. And before closing, I have also the Mentimeter. Sorry for taking you again 5 minutes. However, before going to the Mentimeter, I would like to ask if you have any questions regarding the topics that we have discussed today. So black box testing and testing in general. So no questions? Okay. If there are questions, please go to menti.com and use this code. So 30. This one. So we have the same 3 questions. First, about the concept that you learned today.